Today we're looking at section P5, part 2 or continued, looking at factoring the sum or difference of two cubes. So when you're dealing with cubes, you're dealing with that third power. So for number 1, it says factoring the sum of two cubes. If you have something like an a cubed plus a b cubed, so a number times itself 3 times added with a number times itself 3 times, the way it's broken down is you end up with a binomial factor of a plus b. So whatever that number was to the third power, whatever that number was to the third power for both a and b, you're going to have a binomial a plus b. Then what's left over is going to be an a squared minus an ab plus a b squared. So what happens here, if we have a plus sign, we're going to end up with a plus sign as our first binomial factor. And then we're going to end up with a subtraction sign for our trinomial. Now the piece that looks a little different, kind of the same but kind of different, we have an a squared minus an ab plus a b squared. If you remember when we had that square double squared, this time we don't have that double because the piece was already pulled out to the front, that a plus b. So if you can remember, an a cubed plus a b cubed gives you an a plus b, and then your trinomial piece is an a squared minus an ab plus a b squared. The factoring the difference of two cubes, when we have a subtraction, a cubed minus b cubed, that means that we are going to, very similar, whatever sign started between the cubes is going to be in the binomial factor a minus b. And then when you get to that trinomial, you now have a plus sign. So very similar again, it's just not a square double square, it's a square single square because you already pulled out that a minus b in the front. So let's see what we got. If I have to factor 125x cubed minus 8, so first thing I want to figure out is what times itself 3 times is 125x to the third. Well, 125, let's see, 5 times 5 is 25. 25 times 5 is 125. That means that this is a 5x to the third power, which is that a value is going to be a 5x. Now that minus 8, what number times itself 3 times is 8? Well, that would give us 2 to the third power. 2 times 2 is 4 times 2 is 8. So that means our a value is really going to be a 5x and our b value is going to be our 2. And we follow the process. This has a subtraction sign between those two factors, which means that we're going to have, for our a minus b, we're going to have a 5x minus 2. And then to figure out what would be left over, let's see, I'm going to write this out a little bit more because it's notes. We're going to take the a value, which is a 5x, and we're going to square that. Plus, we're going to take a times b, which is a 5x times 2. And then we're going to add that b squared, which is a 2 squared. And if we simplify that down, that means we have in parentheses a 5x minus 2. And then when I simplify down that next set of parentheses, a 5x squared means that we're going to have a 25x squared. 5x times 2 is going to give us a 10x, and a 2 squared is going to give us a 4. And that's going to be our simplified version. So in general, a strategy for factoring polynomials, some of the things that we did yesterday, some of the things we just looked at today. Step number 1, if there's a common factor, factor out the GCF. Always look to simplify what you have from the beginning. It will make your life easier. Step number 2 says to determine the number of terms in the polynomial and try factoring as follows. Part A says, if there are 2 terms, can the binomial be factored by using one of the following special forms? Now I have a typo in there and I'm pretty sure I still haven't fixed it. So the first type of special case was the difference of 2 squares. That was an a squared minus b squared, which gave you one of each, a plus b and a minus b. The sum of 2 cubes, which is what we just looked at, a to the third plus b to the third, gave us that first binomial a plus b. And the second part, our trinomial, a squared minus single ab plus b squared. And then the difference of 2 cubes, a to the third minus b to the third, gives us that a minus b, and then the a squared plus ab plus b squared. So minor typo in there, which I think I still did not fix on your guided notes. Sorry about that. Part B says if there are 3 terms, Is the trinomial a perfect square trinomial? If so, factor by using one of the following special forms. So if you're looking for that square double square, if you have a square double square with a plus or a minus, you'd have an a plus b squared or an a minus b squared. It says if the trinomial is not a perfect square trinomial, try factoring by trial and error. Part C says if there are 4 or more terms, try factoring by grouping. Step number 3, check to see if any factors with more than one term in the factored polynomial can be factored further. If so, factor completely. Sometimes they like to trick you where you simplify something down and it leaves you with one of those special cases, like you have a 2-term binomial, but it falls into one of those special cases that you need to take one step further. So always double check that. All right, so example of factoring a polynomial. We have a 3x to the third minus 30x squared plus 75x. So step 1 wants to know if there's a common factor, factor out the GCF. So I look at my numbers, 3, 30, and 75. Those are all divisible by 3. We have an x to the third minus a 30x squared, and then we have a 75x. They all have x in common. So first thing we're going to want to do is factor out that GCF. So we said 3 and x would simplify out of that. So 3x times what is a 3x to the third? We would be left with x squared. 3x times what gives us a 30x squared? We would need a minus a 10x. And 3x times what would give us a 75x? That's going to give us a 25. So step 2 says to determine the number of terms and factor accordingly. Well, we have a trinomial, so I might check to see is it a perfect square trinomial. Well, 25 is a perfect square, and x squared is obviously a perfect square because it's x times itself. So I might want to check, is that a square double square? Well, I'd have an x, I'd have a 5, and x times 5 doubled gives me a 10x, which means I have a special case. That means I'd have a 3x, we would have an x, and that would have to be a minus 5. That's going to be squared. Step 3, check to see if factors can be factored further. So it says in this case they cannot, so we factor completely. Inside the binomial we have an x minus 5. There's nothing more that we can do with that. So factoring algebraic expressions containing fractional and negative exponents, this is definitely new. It says, although expressions containing fractional and negative exponents are not polynomials, they can be simplified using factoring techniques. This is going to be ugly, guys. I'm sorry. You could always repeat it a couple times over to see what we do. Factoring involving fractional and negative exponents. So we're going to factor and simplify. They give us an x times x minus 1 raised to the negative 1/2 power. And we're adding with that an x minus 1 to the positive 1/2 power. So it says that the greatest common factor of those two terms is going to be what? So if I look, I see an x minus 1 that's in common, but it says it has to have the smaller exponent of the two terms. So we know that we're going to have an x minus 1 that's in common, but we need to figure out what is that going to be in terms of the smaller exponent. If you were looking at something like, even if we went back to that previous example that we had, when we had that 3x to the third minus the 30x squared, when we looked at something like an x to the third and an x squared, what got factored out would have been an x to the second power, which would be the smaller exponent. So when I look at a negative 1/2 and I look at a positive 1/2, which one is smaller? Well, the negative 1/2 is obviously smaller, right? Because it's negative. So the greatest common factor is going to be that x minus 1 with a negative 1/2 power. So now let's take it to the next step. Once I have my greatest common factor, I can start breaking this down a little bit more. So my x times x minus 1 to the negative 1/2, I already have that negative 1/2 power. So I'm just going to rewrite this as x with an x minus 1 to the negative 1/2. We want a common factor of an x minus 1 to a negative 1/2, right? Our GCF was at x minus 1 to the negative 1/2. So I need to rewrite this piece with this as a factor. So I'm going to use a different color just to organize it a little bit better. I need to have an x minus 1 to the negative 1/2, which means I need to have an x minus 1 to what power in order for these two pieces together to make a positive 1/2. A negative 1/2 plus what value is going to give us a positive 1/2? Well, if I solve to figure out what has to go in that box, I would add 1/2 to the other side. So that box, right, also known as what could have been a variable, has to equal 1. So this little box is going to have an exponent of 1. If I have same base and I add the exponents, I get that positive 1/2 exponent. So now that I have a common factor, just like what we did before, the common factor gets taken to the front. So that means I have an x minus 1 to the negative 1/2 in the front. And then what's left over? What's left over is I have an x and I have an x minus 1 to the first power. So my other set of parentheses, I'm going to end up with, I have an x and then I have a plus x minus 1 to the first power. That looks kind of funny, doesn't it? Let's see what we can simplify it down to. X minus 1 to the negative 1/2. Well, do I really need that first power here? No. So I have an x plus an x minus 1. I have an x plus x, which gives us a 2x, and then I have a minus 1. And that is what our final answer kind of looks like, except I have a negative exponent. What do I do with a negative exponent? Negative exponent has to go to the bottom of the fraction bar, x minus 1 to the positive 1/2, leaving us with a 2x minus 1 on the top. And this is why I said you may need to go back and rewind and just listen one more time. You wrote it down the first time, you can listen to it the second time. We will also do some extra practice in class, so please don't panic.